My name is Jason Brinkman. I am the district engineer for the Idaho Transportation Department. My responsibility is over Southwest Idaho. So I've got the 10 Southwest counties, including Boise, Cascade, McCall area. With me today, I've got a number of team members. Dan Gorley is here. Dan is our design construction engineer on this project, so he'll coordinate the development of the project and then ultimately the construction. Dan McCaffrey is here with me today and will help me present. Dan is with Majeski Maskers. He's our nationwide bridge expert that's going to advise on this design of this project and help us through the technical aspects of bridge design. Rosemary is here today. Rosemary is helping us with the public outreach and communications on the project, so very important part of getting us coordinated to be here today. ITD is planning to build a new bridge over the North Fork of the Payette River. So you're almost certainly all familiar with where this existing Rainbow Bridge is today. We'll be building a new bridge that we anticipate will be next to this bridge. And then we'll be determining what the future is of the existing bridge. That existing bridge has been in place since 1933, so it's over 90 years old. By the time of replacement, we'll be almost at a century when the new bridge would get constructed. So it's had a good long service. Purpose of this group, we're calling this the Bridge Involvement Group. We're also having public meetings, but this is the group that will be most involved in providing some of the detailed and specific input of what we're looking for with this bridge project. So we're going to give you some of the inside scoop on the bridge, and we're looking for your feedback specifically on how we move forward with certain key elements of this project. You are our key stakeholders, so we want to make sure that we have good representation from the communities, from emergency service providers, from commerce and industry, and road users, and even some of the recreational uses in the area. So this is a group that's representing really all of the stakeholders on the project. And out of that, we would ask for your help in communicating our project plans with the wider community. It's a little bit hard to reach everybody that ever drives Highway 55 or has an interest in this bridge, but you know a lot of them, and that's where part of what your role is, if you'll be willing to help us with that. We have a series of 3 meetings planned with this group. This is the first one, and at this meeting we're going to introduce the project. This fall we will have quite a bit more detail on design options for the new bridge, as well as what we see as our feasible options for dealing with the existing bridge and what might become of that in the future. And then we'll circle back sometime in 2025 with what our outcomes are, what our recommendations is, and the ultimate decision on how we move forward with the project. After each one of these meetings, we'll have that series of public meetings. So those are scheduled next week in McCall and Horseshoe Bend. We'll follow that format for each of these. So you kind of get the early look, the inside scoop, and then we'll do the public meetings after that. Today's meeting, again, is to introduce the project. We're also going to ask for your input. We want to know what issues we should consider as we go through the development and design process on this bridge. What things are important to you? How should we look at this? Are there things that we don't know about in the area or that we need to consider as we design the new bridge? We'll talk about some potential bridge types and the locations of where that bridge might be, what we're looking at for that. And then at the end here today, we'll get into some of what we're thinking with regard to the future of the existing bridge. Let's talk about the history of this bridge. I mentioned that it's over 90 years old. It's going to be 100 soon. This is a Depression era bridge. So this was built in 1933. The funding for it actually came from the New Deal. This was a major work at the time, and this completed the link for this section of the canyon, which was previously pretty difficult to navigate. So this was an important link to make it possible to travel between the Boise area and the McCall or Cascade areas. The quotes at the time would kind of astound us in today's terms, right? Down to a 7-hour trip, very reasonable travel time at the days back in the day, but with no particular pressure on the driver. So I don't know if you've been followed on 55 lately. I feel a lot of pressure if I'm driving anything other than the speed limit. So why build a new bridge? First of all, old bridges at some point become challenging to maintain, and this bridge is no exception. The aging concrete will start to show its age. You'll get erosion and delamination of the concrete. The rebar that's inside the bridge, in this case some old square bar, will start to get significant corrosion on that bridge, which then contributes to the concrete delamination. There are cracks that become visible or grow in the concrete or in the bridge. We inspect bridges like this frequently. The frequency of those inspections starts to pick up, so we have to start paying a lot more attention to the bridge to make sure we're staying on top of its changing conditions. And we do that to make sure that the structure stays safe. So I wanted to emphasize the fact that this bridge is safe today. It's inspected regularly. There are no restrictions on the bridge. So while the bridge itself is not new or modern, the bridge is certainly suitable for traffic today. But we know that won't be the case forever. So we're going to work diligently to keep that bridge safe for as long as it needs to remain in service for traffic. But we know the day is going to come soon when we need a new bridge to carry that traffic. The other reason for a new bridge really is to get this section of highway and the bridge specifically in line with modern highway standards. The existing bridge is narrow. The existing bridge doesn't have any shoulders. The curves on the end are restrictive. If you've been by this very often, you notice the rails have been hit before with wide loads or errant vehicles. And there are vehicles that are not permitted on the route in part because of this restriction at this exact bridge. So this bridge is not up to what we would use for the standards of how we would design a bridge today. It's also not feasible to widen or significantly improve those features of the existing bridge. Some bridges, you can add another line of beams, another line of girders, or put a wider deck on. This bridge, that really isn't feasible to do that with. So there's really nothing that can be done to the existing bridge that would make it meet the standards, the widths, and the alignment that's needed today. We've put some amount of effort into this bridge already. Back in 2021, we initiated what we call a feasibility study. This feasibility study was how ITD went out and solicited some specific information about where could we put a new bridge, what could we do with the existing bridge, could it be widened? We looked at that at the time. And what that study concluded is what we're telling you today about the need to build a new bridge. The study also started to get into what some prospective bridge types there might be, and you can see on the cover a different rainbow bridge in front of the old one. So at least one of the notions they advanced was, a bridge much like the existing one, just upstream of it. There's a lot that the department has to do on a project like this. Foremost on all these projects, we have to consider the environment. There's a lot of environmental studies that we'll do, and we'll spend quite a bit of time documenting wetlands and endangered species. And this bridge will have cultural resource work owing to the fact that the bridge and the highway itself are historic. There will be a number of technical studies. You see us there surveying the river. We have to make sure that we can accommodate river flows and runoff and drainage, as well as obviously the bridge design, the roadway design, the slopes of the mountain above and below this. We have meetings like these. We get your input, we ask for the community's involvement, and then we'll design the alternatives for a new bridge. We will ultimately also have to make a decision about the old bridge in the course of this project, and we'll generate the entire plan and specification documents that we'll use to ultimately hire a contractor to build the new bridge and put construction plans together that are currently targeted for approximately 2028 or 2029. That sounds like quite a ways in the future. In bridge years, it goes pretty quick. But we're going to take every advantage we can of trying to accelerate this project to meet or beat that if we can. So that's where it sits in our program right now. We'll see as that grows closer what our actual construction year will end up being. We know this is a challenging location. If you've traveled the corridor lately, you might see we occasionally have flaggers out there. We're doing some drilling and investigation on this site already. And even that is challenging with steep slopes and narrow access paths. We have not decided yet what we're going to do with the existing bridge, and we've not decided yet what the new bridge will look like. So this process is going to develop that, and we'll bring you along as we develop those concepts. But we wanted to start early and get your input into those decisions. And so that's really what the group here today is about. We will, through the design, come up with a new bridge that'll serve for at least the next 75 years. Bridges can go longer. The existing bridge went longer, but we'll be designing something for a minimum of the next 75 years. There will be some highway improvements in the area immediately adjacent to the bridge as we affect the curves and the slopes that come in and out of the bridge. This project isn't set to do the whole canyon, though there will be future work on the canyon itself, but this is going to address enough of the approaches, enough of the roadway on either side to get on and off of the bridge safely. Part of that is going to take some retaining walls. You can see the very steep slope there where the trees are missing. That's just downstream of the bridge. The new bridge proposal will have to deal with places like that, and so there will be almost certainly some retaining walls and some rock cuts and other things to deal with as we get onto and off of the new bridge. So part of the work of this bridge project will be some of the slope work and retaining walls that get you to the bridge as well. We will, in the design phase, consider what type of bridges work at this location. There's a lot of type of bridges out there. I'm going to let Dan go into that because Dan does that for a living. I work on highways more broadly, but we'll ask questions of ourselves like whether steel or concrete for the bridge is more appropriate at this location. Which is more constructible, which is more durable, which is more cost effective. We will do a lot of studying of the rock and the soils, and we'll look at how the rock up here will weather, how these slopes will hold up over time, how we retain the soils with walls or things. We have a railroad crossing at this location as well. Most people don't think much about it, but the railroad that runs along the river here also crosses under this bridge where it leaves the highway alignment. Railroads, even though this one isn't in operation today, railroads have very specific operational widths, heights, and criteria for how we treat the railroad tracks. We will draw up what we call typical sections. This is the width and features of the roadway. So how wide are the lanes and the shoulders and offsets for things like turning trucks. We will look at the flow in the river, the hydraulics, how much water to expect in the North Fork Pay at, and how far that comes up into the bridge span. We will look at maintainability. So can we build a bridge that is low maintenance and high performance over the long term? And we make sure that there's safe access for the annual or biannual inspections that we have to do. We look all over a bridge at least every 2 years, under it, over it, around it, and we need to be able to do that safely. And obviously in this location, we have to be able to plow the snow. I mentioned constructability earlier. It is going to be difficult to get some of the large cranes and equipment to this site where they need to be positioned in order to build this new bridge. That kind of has to be taken into account in the design. We need to design the size of the components, the weight of elements and things such that they can be delivered up the highway and then put into place over the river at this site. So that's not something that we take lightly. That'll be part of the design, is considering how the bridge would actually be built. And then of course, we are very interested in what the community input is on this bridge and what features you value and how we can reflect those in the design. The curvature, the narrow approaches to this bridge right now is something that we call alignment. Alignment affects more than just how fast you can go. It also affects how far you can see and ultimately safety. So we're very concerned about the alignment of the bridge we build. That'll be a big part of the design. The speed sort of follows from that. We'd rather not have speed restrictions on the corridor. So we'll look closely at what the speed of this section is designed for as you cross a new bridge. You probably slow down a little as you pass the bridge today. Hopefully you won't have to do that at least as much in the future. And then we also, as well as the constructability, will look at the construction impacts. So how does our construction affect people using the highway? Will there be flaggers or delays? Will we need any closures? How will that affect people that are traveling the road during our actual construction project? We will look at how water from the bridge and from the roadway and from the slopes gets to where it needs to go over time. Make sure that we don't create any erosion or put any sediment in the river. We'll look at how we design those retaining walls, how we finish those walls, so what the face of those looks like, or how they're specifically built, both in terms of their function and their form, so what they look like and how they work. So I realize that's a lot. I've gone through it pretty fast. But our first question for you, is there anything we haven't thought of? Are there other issues that you'd like us to consider as we embark on this project?
As Jason mentioned, I'm from Majeski and Masters. We are a bridge-focused engineering firm. I'm the assistant director for our national bridge group, and we focus on unique, complex, long-span bridges. So my career really has been on arch-type bridges, truss bridges, suspension bridges, cable stay bridges, things like that. So this is the kind of stuff we do regularly, and it's actually kind of fun. So you see here, this is the existing location. This picture is from a drone looking south. Things to note are the curvature, as Jason already pointed out. We've got the steep slopes on the sides. We've got the railroad crossing. And this yellow highlight here is the anticipated new alignment location. We're still looking south, so that bridge, the new bridge, is going to be to the north, upstream, toward McCall. Boise is to the south. Flipping the view just a little bit here, to the south is now to the left. You can see Boise to the left, McCall to the right, north is to the right. It's a little bit easier to discuss the alignment from this view, from this aerial view. So these bullet items on the right here are essentially the criteria that we were looking at as we're going through trying to determine what's the best alignment, what's the best location for the bridge. The feasibility study that Jason mentioned that was done in 2021 recommended a similar alignment. There were some other alignments considered that were to the south and a little bit further away. We started our work using their work as kind of the starting point and did some refinements from there. One of the biggest things as we get into a project like this is minimizing the impacts, the environmental impacts, the physical impacts. In order to do that, you really want to keep your footprint small. So that forces you to want to build the new bridge close to the existing bridge as possible. The further away you are, the more roadway you would need to build to get to that location, the more physical impacts you would have. The other thing that we wanted to minimize is any cuts to the steep slopes that were there, especially the things that we learned coming out of the recent Smith's Ferry project, the challenges associated with cutting into these slopes. So you can see these squiggly lines right up here. Those represent retaining walls. Likely, maybe will be benched. That's still under consideration. But in order to make the alignment to fit in there, there will have to be some cut. But what we've done is we've minimized it by trying to stay as close to the existing bridge as possible. As Jason mentioned, the future of the existing bridge is still not known. So one of the things we wanted to keep in mind is we wanted to be as close as we could to the existing bridge, but not actually touch it, so that we wouldn't actually disturb it, so that in case it's staying in its fullness, we want to make sure that we're not affecting it in any way. Right in this area here, we've kind of squeezed as close as we could to the existing bridge without actually touching it. Down on this end, we actually eliminated some of the cuts that were anticipated there by adjusting the alignment to just kind of peel into the existing alignment, and we have a little bit more retaining wall right through here as opposed to having a cut through this area. So that was some of the improvements. As Jason mentioned, the curves are a big deal. The barriers there, you can see very clearly, right in this area, they get rubbed, they get hit. And so the sharp curves there with a small radius is really a challenge for drivers. So the new alignment has proper curves that help to maintain the design speed through this section. Not only does it help you physically navigate the area, but it also improves your sight distance. As Jason mentioned, ultimately, alignment is all about safety. Another feature you can see here, perhaps most observable there, the yellow line represents the double yellow that you would see in the road. The white line represents the lane line. Everything outside of that is the shoulder. So we actually have some fairly wide shoulders in this area. And really that's to push the barrier kind of away and enhance your sight distance. So as you're driving around the curve, There's no barrier in blocking your view, so you can see where you're going. And we have that on both sides. In terms of the space between the two bridges, we're about 200 feet plus or minus between the two bridges. So as I mentioned, we want to get as close as we can to minimize the footprint. However, we need to have a minimum distance apart to be able to fit the curves in. Fortunately, the alignment does give us some space to allow the contractor to get in there to do the work. Constructability, as Jason mentioned, is going to be quite challenging. One thing I do envision, although we don't normally tell the contractors what to do as designers, there is an option, which is part of our design. We kind of imagine perhaps being able to come in here and set up right here, which is actually right in the middle of the new bridge, to be able to reach with a crane or something like that. So this alignment does provide access for constructability. So to summarize all of that, we want to minimize our physical and environmental impacts, so we've kept everything as tight to the existing bridge as possible. However, in order to provide the safe alignment, it's a reasonable space away. That's how we've landed at this current alignment. It hasn't been 100% finalized yet, but this is what we're looking at. Which brings us to the next question. Is there anything else that we should be considering about the location or the alignment beyond what I just mentioned? As Jason mentioned, not every bridge type makes sense at every location. As I mentioned, I've done a lot of work with truss bridges, suspension bridges, cable stay bridges. Those are a bit too big for this location and unnecessary. They don't quite make sense. Could some of them be done? Maybe, but it doesn't quite make sense. There's a few that do make sense. So we're currently investigating 2 concrete arch options, a steel arch option, as well as a steel girder option. And girder is just an engineering term for a beam. The one concrete arch option we're looking at is one that has multiple columns on the arch. It's a very traditional design, very classic, very similar to the existing Rainbow Bridge. Arches do like to be loaded along their entire length. That makes them more efficient. Having multiple columns is an efficient design. This one actually is about the same scale as Rainbow, around 200 feet per end to end of the arch span itself. The existing Rainbow Bridge in 1933 was built cast in place concrete. They actually built the formwork for the bridge in the shape of the bridge and poured the concrete in there at the site. We don't really do that anymore. Nowadays, most things are precast. For example, in the case of this bridge, each half of the arch segment was cast off-site somewhere and then shipped to the site, connected in the field with steel that goes through it, kind of squeeze it together, some concrete closure pores that fill in the gaps. So that is a slight difference. But what that also means is that you're dealing with heavier pieces. Concrete is heavy. Usually, concrete bridges require bigger equipment because they're just big, heavy pieces that need to be lifted, as well as transported to the site. Another concrete arch option we're looking at is one that just has essentially a single support in the middle. Here's a couple of examples. This would be different enough from the existing bridge. So it's a little bit more of an open, modern looking feel as opposed to the traditional design. It would be built quite similarly using precast pieces. There's a famous one in Tennessee. These samples are obviously a bit taller and longer than Rainbow, but they have their own aesthetic merits. Even though this is slightly less efficient of a design than being loaded along the entire length of the arch, it's still very reasonable, very feasible. We're also looking at steel arch options. Here's a couple of examples. In all of these cases, we would use multiple columns. Some of the benefits of steel is that steel is generally lighter, so you need smaller equipment. It's easier to transport, easier to assemble. Additionally, it's a bit easier to repair. It's a bit easier to bolt things onto steel than it is to repair concrete that's falling apart. That one on the lower left is under construction. That picture is just a couple of weeks old. I was the lead designer on that one. That's a arch bridge in Pennsylvania. So I think we would end up looking quite similar to this one up here, except we would only have one span over the river. And we're also looking at steel girder bridges. Like I said, girders are beams. This would be more of your standard overpass type bridge that you're familiar with seeing throughout the state. Very simple, very efficient. Some would say not much to look at. You have some opportunities to bring in some aesthetic things, like the piers here have a little bit of a detail there, or this was cut to be a little bit of an arch shape, but it is still a beam, not an arch bridge, even though it looks a little bit like an archy shape. So we are looking at a girder option that would be kind of the simplest baseline you could consider. We're looking at these different alternatives, and ultimately our goal is to compare them against a bank of criteria: cost, constructability, aesthetics, durability, maintenance, all of those sorts of things. And as part of the process, then we kind of score them and essentially come up with a recommended alternative that gets presented to ITD, and then we go through the process to actually pick one. And that'll be sometime, hopefully later this year, as we start making those recommendations. Is there anything else that we should be looking at or considering? Any other criteria that we should be comparing the options?
So if you spend any time in engineering school like I did, that part's pretty exciting, right? Figuring out how to design a new bridge, especially what is, by all accounts, a landmark bridge. Believe it or not, I actually participated in contests when I was in college, building scale model bridges and competing them. So it's kind of the fun stuff for engineers to consider. We'll have a lot more to talk about the new bridge. If you remember, the next meeting is all about features of the new bridge. So a little teaser for that. Please come back. We want your continued input into the design options we come up with. Dan, I think, has a lot of great ideas on how we can go with this, and we're eager to show you what we'll come up with there and get your continued input on that. In the meantime, I want to talk about the existing bridge. ITD is very fond of this bridge. This bridge is on more postcards and t-shirts and logos than just about any bridge in Idaho. This is a landmark bridge. This is also a little bit of a unique bridge in Idaho in that this bridge is already on the National Register of Historic Places. So anytime ITD does a project, we consider whether the features that we're touching are eligible for the register. But this bridge is already there. So we know this bridge is historic. So in addition to whatever place or view or aesthetic values it has, it's also been recognized as a historic structure. The challenge of that is that this bridge can't be maintained to handle traffic forever, right? Over the long term, we're going to get to a point where we can't efficiently keep traffic on this bridge, thus the need to build a new one. We have previously said, back when we were doing the feasibility study, we want to consider keeping this bridge. That is still a consideration. Can we keep this bridge? Can it be maintained over the long term? What would that take? And what kind of a long-term expectation could we have? Is it going to look like, the Roman Colosseum and it'll just be some ruins, or will it still look like a bridge? Would you be able to walk on it, or would it have to be fenced off, right? So we want to look at, can we keep this bridge? We also know, based on the condition it's in today and the way that the condition is going, it may not be feasible to keep this bridge forever. So we're going to do a lot more work on that as we move forward to figure out, can we or can't we? What does that maybe look like? We know we have to keep this bridge functional until that new one is done, and we will do so. There are minor issues on the bridge today that are going to take some short-term fixes. So we are planning on a project next summer to do some repairs on this existing bridge. Those are necessary to keep the existing bridge in the condition that it can be open and unrestricted for traffic. So I definitely want to emphasize again, this bridge is completely safe today, but we have to design for the next earthquake, the next 1,000 trucks, the next 10 years of keeping this bridge safe while we build a new one. So there'll be that repair project next year to keep it in that case. There will be some short interruptions and closures while we're doing that, and we'll have more information out on that as we develop those. So there might be some times when there's a flagger and a short delay at a flagger station, or we might have some, longer closures, say middle of the day, like we did when we were doing the Smiths Ferry project. So we'll figure out, based on exactly what those repairs are going to take, what that'll look like. It's hard to get underneath the existing bridge. There's not a lot of access, and so we kind of have to do that off of the bridge unless it's disruptive. So we'll keep that minimized, but just wanted to give a heads up that we are going to be working on the bridge in the meantime. We still need to know your thoughts and the community at large's thoughts on the existing bridge. Part of the reason for this outreach is to get your thoughts on the new bridge. Part of the reason is to get your thoughts on the existing bridge. So if you have a strong opinion about what we do with this existing bridge, that's something that we want to hear. We will be looking at what options are feasible. So if we're to keep this bridge, we need to evaluate what we need to do to it so that it stays in an acceptable condition. So we'll be looking at, what we would have to do to the bridge in order to keep it. It's kind of like, keeping paint or roof on your house, right? How many times am I going to have to do that? Or do I need to replace the siding? We need to look at the elements of this bridge and say, do I need to replace some concrete? Do I need to shore anything up? Or what would I need to do to keep this bridge long term? And then, besides what we're doing next summer, what other repairs would we need to schedule and do to keep it? That's going to lead me to this question, and I realize I haven't given you a lot of information to go on, but based on what you know today, what are your thoughts about the existing bridge? What would you like us to consider as we're figuring out what to do with that existing structure? I mentioned public meetings next week. On Tuesday, we will be at the Evergreen Hotel in McCall. Please feel free to join us again there. We hope to get a bunch of the public as well. We will be there from 4 to 7 p.m., so drop in anytime. We will be in Horseshoe Bend on Thursday, July 25th, also 4 to 7 p.m. at the school. So whichever one's convenient, or come to both, by all means. If you have a smartphone and you want to hit that QR code, the invite's in there as well, and then you'll have the information on your phone. Next steps, we're doing these series of meetings. We already did that feasibility study. We've initiated the project, so we're here on the community engagement in July. We are starting on technical and environmental work, so that's getting rolling as we speak. We're out there doing the geotechnical investigation. We'll be back next for this fall community engagement, and the determination of what to do with the existing bridge as well as the new design are going to come together roughly contemporaneously over the rest of this year and into 25, maybe 2026. So over about the next year and a half, say, is really the process and the time frame where we're going to go through developing all the details of what the new bridge looks like, and we'll work through all of the process on what becomes of the existing bridge. And then, as I mentioned before, construction is currently scheduled for 28-29 timeframe.